Lesson 15.7 is Interpret Data Distributions. We don't have a warm-up video today, so go ahead and make sure you write down your homework and then write down this vocabulary. The distribution of a data set can be described by its center, spread or variation, or overall shape. You can also describe the distribution using symmetry, clusters, gaps, and peaks. We want to use the range to describe the spread of the distribution. Okay, so make sure you have all of these colors written down. So a cluster occurs when data values are grouped together. That's a cluster. A gap occurs when there are no data values. Okay, so that means that there are no, if we have a histogram, there's going to be no bar there. If we have a line plot, there's going to be no dots on the number line. A peak is the most frequently occurring value in the data set. So if it's the most frequently occurring value, then of course we call that the mode, right? So that's going to be the peak. Another name for the peak is the mode. Let's put that in. And in a symmetric distribution, the left side of the distribution looks like the right side of the distribution. So it's like a mirror image, okay? So it looks kind of like this, like if we had something like that. You see? Looks the same on both sides, okay? So here's an example of that. This is a symmetric distribution, okay? So this distribution is symmetric. It looks the same on both sides. So, and you can see that it goes like this, see? Oh, just like the picture I drew up there. Okay, so this is symmetric on both sides. The spread of the data is 4 movies. And the spread, of course, that is the range. We set it up here. Oh, we set it up here. So we're going to use the range to describe the spread of the distribution. Okay? So the spread, or the range, is 4. And you can see that 6 minus 2, that equals 4. And there are no clusters or gaps in this data set. And, let's see, there's no gaps because there's no zeros in between. There's not a place where there's no dots. And then there's a peak at 4 movies. So here's the 4. This is the highest. So that 4 will be the mode. That's the peak. Here is an example of a line plot where the data is not symmetric. So it says a distribution that is not symmetric has skewness. When the majority of the data values are to one side of the display, the distribution is skewed in the opposite direction. Let's write that down. So it is skewed when the majority of the data values are to one side of the display. So here you see this diagram. This is not symmetric. It's not the same on both sides, so we can't fold it in half, and it's not the same on both sides. There is a gap from 5 to 8 movies. So here there's a gap right in here from 5 to 8 because there's no dots. That's what I was talking about. The data are skewed right. They're skewed right because most of the data, you see this? Most of the data is over here on the left. So it's skewed right. Okay? It's kind of opposite of what you would think. Okay? So it's skewed right. So, or you can say it trails off to the right. Okay? There is a peak at 2 movies. So here's the peak at 2 movies. So that means that the mode of this data is 2. There's a cluster from 1 movie to 3 movies. So you can see here that most of the data occurs right here between 1 to 3. Okay? And then the spread of the data, or the range, remember we said spread means range, is the highest minus the lowest. So that's going to be 10. Let me use a different color. So that's going to be 10 minus 1, not 0, because there's no dots here. So it's 10 minus 1, which gives us 9. So that's the range of the data. Now, when most of the data values are to the right side of the line plot, then the distribution is skewed left. So here, most of our data is right here. You can see trails off to the left. You see that? So this is skewed left. Okay? The distribution is not symmetric, and again, you can't just fold the line plot over from 0 to 9, fold it in half, and you can see it's not the same, so it's not symmetric. It is skewed left because most of the data is on the right. There is a cluster from 6 to 8, so most of the data is right there. There is a gap from 1 to 5, so there's no dots up here for 1 to 5, so that is the gap. And there's a peak at 7. So 7 is the mode, and that's the spread is 9 movies again, this time, because the highest value is a 9 right here, and the lowest value is a 0. So 9 minus 0 is 9. Okay, you got to make sure you pay attention to where the dots are. All right, so for example 1A, says tennis players were asked their age. The line plot shows the results. We want to use clusters, gaps, peaks, outliers, symmetry, skewness, and spread to describe the shape of the data distribution. Now, if you look at it, you can see if the middle is right here. The middle is right there. So if I fold this in half, it's right on going to be, it's going to be exact, right? So this has symmetry. So because it has symmetry, there is no skewness, okay? So because it has symmetry, there is no skewness. The distribution is symmetric, okay? The data is distributed similarly on both sides of the graph, okay? The spread of the data is 8 years. So if you took the highest number, the highest data value, that's 33, and the lowest data value, that's 25. If you subtract 33 minus 25, that's going to give you 8. So the spread of the data is 8 years from the youngest to the oldest player. Okay? So you can see here that most of the players are between 28 and 30. Okay? Now, on this graph, there are no clusters, gaps, or outliers. Okay? So there is not like a group of numbers all in one section. So there's no clusters. There's no gaps because we have dots at every single one of the tick marks here in the number line. And there are no outliers. There are no numbers that are very, very high or very, very low. So there are none of those in there either. All right, example 1B says interpret line plots. It says the result of a class survey about the number of hours spent on the internet each week by students are shown in the line plot. We want to use clusters, gaps, peaks, outliers, symmetry, skewness, and spread to describe the shape of the distribution and summarize the data. So go ahead and press pause. I have my answers over here. So press pause and then you do your description and then press play again to see what I've written on the right. All right, so the first thing you should notice is that if you fold it in half, it's going to be the same on both sides. So the distribution is symmetric. So that means there is no skewness, okay? The spread is from 1 to 7. So here, every student spends from 1 to 7 hours on the internet each week. So the spread, or the range, remember I said that's another name for the range, is 6. So that's the highest, 7 minus 1, that's 6 hours. So the spread is about 6 hours. Most of the students are right here, okay? So most of the students spend from 3 to 5 hours on the internet each week. And then finally, you don't see any holes in there. You don't see any clusters, and there are no outliers. So here, there are no clusters, gaps, or outliers in this data set. All right, so now we're going to interpret histograms. Like line plots, you can also describe the spread and distribution of histograms, including the symmetry, the skewness, the gaps, the clusters, and the peaks. Now, in a symmetric distribution, the left side of the distribution looks like the right side. So just like with the line plots, if you fold it in half, it's going to look very similar. Okay, so if you look at this example, the distribution is symmetric. So there is no skewness here. Okay. There are no gaps. Okay, so you see a bar for the histogram in each one of these intervals. So there are no gaps. There are no clusters. Okay, we don't have any groups of data in one place. There is a peak. There is a peak at 56 to 60 tickets. So here's the peak right here. So again, remember, the peak means that's the mode, right? So there's a peak right here. Let's see, and the range is between 41 tickets, because that's the lower end, and 75, that's the higher end. The range is between that. So we could say that the spread is 34. Because remember, the range is just the highest number minus the lowest number. Okay? All right, so when a distribution is not symmetric, the data are sometimes skewed. Okay? So here's an example of one that is not symmetric. In a skewed distribution, most of the data, again, will be on the left or the right side of the histogram. If most of the data is on the left, then that we say skewed right. If most of the data is on the right, then we say skewed left. Okay, so it's kind of opposite. So here, let me read the rest of this. It says, in a skewed right. Oh, this is what I just said. All right, so looking at this histogram, it says the distribution is not symmetric. You know, because if you fold this in half, it's not going to be the same on both sides. The data are skewed right because most of our data is over here. So that means it's skewed to the right. And you can also say, oh, look, it trails off to the right. Okay. There is a cluster from 400 to 799 feet. So most of our data is right there. There is a peak at the interval between 400 and 499. So that is the mode of the data. And the range is between 99, the highest number is 99, and the lowest number is 400. So the range would be 599 feet. So the spread is 599. Okay, that's how we are describing the distribution. So in a skewed left distribution, this is an example of skewed left, there's more data values on the right side of the histogram. So just like this one, see here's all that data right over there on the right. So that means this is skewed left. Okay. Then we can look at the rest of this. So let's see, the range is between 71% and 100%. There is a cluster of data right here. between 81 and 100. That's a cluster right here. You can label it if you want to. Cluster. The data is skewed left. There is a peak at the interval between 91 and 95, right there. There's the peak. That's the peak. And look at this, there's a gap. We haven't had one of those yet. So there's a gap between 76 to 80. And that's what it looks like on the histogram. Okay? All right, so example 2A on interpreting the histograms, it says, the histogram shows the number of laps each student walked while exercising. Use symmetry, skewness, gaps, clusters, peaks, and range to describe the shape of the distribution and summarize. So here's our histogram. I can't fold this in half and it be the same on both sides. So this is not symmetric. This data is not symmetric. The data is skewed left. I mean, now I'm going to tell you it's very tight here, but most of the data is on the right and it trails off right there. So this is skewed left. Okay? Every student walked between 1 and 14 laps. Every student walked between 1 and 14 laps. And the spread is 14. You know, I think I'm going to change this. I think because we go all the way, this is 0 to 2, 0, 1, 2, you see? So who knows, we could have somebody who walked 0 laps, right? So I'm going to change this to 0 to 14 laps, okay? And of course, the spread is 14, okay? There is a cluster from 6 to 11. Oops. There is a cluster from 6 to 11 right here of data. So most of the students walked between 6 and 11 laps. And there is a peak at 9 to 11. So this is where the peak is. 9 to 11 laps. And there we go. So here's example 2B. It says the histogram shows the wait times in minutes for entering a concert. Use symmetry, skewness, gaps, clusters, peaks, and range to describe the shape of the distribution and summarize the data. So again, I want you to pause the video, do this one on your own, and then you can scroll down and you can press play, and then you'll see what I wrote. Okay? So the first thing we notice is that we cannot fold this in half and it be the same. So we know that this is not symmetric. Okay? You can see that's not symmetric. You can see that most of the data is on the left. So that this means this is skewed to the right. Okay? The wait times range from 0 to 99 minutes, and there's a cluster from 0 to 49. See, 0 to 49. The data is clustered right over there. That means that most of the wait times are between 0 to 49 minutes. Okay? The greatest and fewest wait times, so here the greatest wait time is right here. There's a peak between 20 and 29, and the least is down here between 90 and 99. Okay? And you can also see that there are no wait times right there. There are no wait times between 50 and 89, and of course we call that gap. All right, so that is interpreting line plots and histograms and the data distribution. So now you can work on your homework, which is IXL or ZL, and it's described distributions in the line plot. And you notice you didn't really have to show any work for this one. So for this IXL, you don't have to show any work.